Hello there. This is Sir Mads and welcome to Maths Help. Today we're going to talk about two special logarithms and how we can solve problems using them. Let's get started.
Common logarithm is defined as the logarithm to the base 10. You'll see there below it says y is equal to the logarithm of x to the base 10 is just equal to the expression the common logarithm of x. In other words, when you see the logarithm operator without any base, it is understood that it is the common logarithm, or that the base is 10. Similar to our previous lesson, we can also rewrite the common logarithm expression into its exponential form, such that when you have y is equal to the logarithm of x, its exponential form can be rewritten as 10 raised to the y must be x. Let's work out a few examples. In this first example, we are asked what is the common logarithm of 10 to the 9. Now, we can let the common logarithm of 10 to the 9 be y, and in which case we can rewrite this into its exponential form. 10 to the y must be equal to 10 to the ninth power. That is the same as being asked to what value of y do we raise 10 to get 10 to the ninth? Quite obviously, we know that y must be 9. Therefore, the common logarithm of 10 to the ninth must be 9. In this second example, we are asked what is the common logarithm of 100. Now, if we let the common logarithm of 100 be y, we can again rewrite this logarithmic form into its exponential form. In essence, that is 10 to the y is equal to 100. Again, that is the same as being asked to what value y do we raise 10 to get 100. Now, we do know that 100 is 10 squared. So in essence, you are being asked to what value must you raise 10 to get 10 squared. Evidently, that must be 2. So what is the common logarithm of 100? That is 2. First, we are going to substitute 102 into the expression. Thus, we're going to get 102 minus 2 squared, which is 100 squared. Now, do remember that 100 is 10 squared. So, 100 squared is 10 squared squared, which is 10 to the fourth power. So, the expression 2 times the common logarithm of the quantity x minus 2 squared.
Now that you've learned about the common logarithm, let's move on to the next special logarithm, the natural logarithm.
Another special logarithm is called the natural logarithm, and it is defined as the logarithm to the base e, where e is the natural number. Now, it is denoted by a new operator, ln. When you see this symbol, it means the natural logarithm of x. E, or the natural number, is an irrational number, which is commonly approximated as 2.71828 or 2.72. Now, just a note, in Commonwealth English countries, they do not adopt the operator ln to mean the natural logarithm. They maintain the same operator log, or the logarithm, and they maintain writing the base as e. As in our previous lesson, we can naturally rewrite the natural logarithm into its exponential form. So when you have y is equal to the natural logarithm of x, that is equivalent to saying e raised to y must be x. Now let's do a few more examples. Do remember that in this exercise you ought to round your answers to the nearest whole number. Also, the use of calculators or any computing machine is allowed. In this first example, we are asked what is the natural logarithm of e raised to the fifth power. Now, if we are going to rewrite the natural logarithm of e raised to the fifth power as y, then we can rewrite that into its exponential form, which is e raised to the y must be equal to e to the 5. Or equivalently, we are asked to what power y must we raise the natural number e to get e to the fifth power. Evidently, y must be 5. So if you are asked what is the natural logarithm of e raised to the fifth power, that must be 5. For the second example, I am going to leave this to you to take advantage of the aid of the computing machine. Assuming that you are going to operate correctly your computing machine, one should get that the natural logarithm of 1096.6 is equal to 6.9999 and so on, or approximately 7. In this third example, we are asked, to what value does the expression negative 3 times the logarithm of the quantity x plus 2 squared to the base e must be equal to if x is 0.72? One will have to realize that upon substitution of 0.72 to the expression x plus 2, then the operand inside the logarithmic operator becomes 2.72 squared. That can be approximated into e squared. Therefore, the original expression can be approximated as negative 3 times the logarithm of e squared to the base e. For simplicity, we are going to deal first with the expression the logarithm of e squared to the base e. Now if we are going to replace that as y, then we can rewrite that into its exponential form, which is e raised to y is equal to e squared. Obviously, y then must be 2, or that the logarithm of e squared to the base e must be 2. This means then that the expression negative 3 times the logarithm of e squared to the base e can be simplified into just negative 3 times 2, which means that negative 3 times the logarithm of the quantity x plus 2 squared to the base e when x is 0.72 is approximately negative 6. Here are a few more examples that I'd like you to work on at home. Do realize that this is a mixed practice and that many of the items here does not involve only the special logarithms, common and natural logarithm.
Learning to solve problems takes practice, and I really hope that you're going to answer the problems that were prepared for you at the end of this lesson so you can practice some more at home. That's all for today, and see you next time. Bye bye.